Good morning and welcome to day 4 of our winter theme week. Today we are continuing our winter theme week with a fun STEM challenge. This is called a sled STEM challenge. So I just want to say before I get started with the STEM challenge, there is nothing that you need to build or create today. I will show how I did the sled STEM challenge, but you do not have to do it. I know some of you enjoy doing STEM challenges, so you can do it if you want to, but you do not have to for today's assignment. Your assignment is to just watch the video that I made of me doing the STEM challenge. You're going to answer a couple quick questions about the STEM challenge, but you do not need to create anything today, okay? So let's get started. Today is the sled STEM challenge. All right, let's get started with today's sled STEM challenge. So let's first review what we learned yesterday. If you watched yesterday's assignment, we learned a little bit of science about sledding. We learned that the taller the hill, the faster the sled will go. And we learned that the smoother the hill, the faster the sled will go. Because when it's smoother, there's less friction, so your sled can go faster. But what if the hill is the same and the sled is different? That's what we're going to look at today. What if your hill is the same, but your sled is different? For our sled challenge, we are going to build 3 different sleds using different materials. And then we're going to test each sled to see which one will go the farthest. All right, here are the materials that I used for the sled challenge. I used some pipe cleaners, craft sticks, index cards, some pencils, tin foil, masking tape. I used a cereal box that I cut up for the cardboard, and then I also used a couple straws. All right, so you are now going to see the 3 sleds that I built for the STEM challenge. Your job first is to look at each of the 3 sleds and predict or guess which sled will go the farthest. So first, let me show you the 3 sleds, and then you can guess which one you think will go the farthest when I test them. So this is my first sled. I made it out of tin foil, and there's a pencil on each side that I kind of wrapped in the tin foil. There's an index card here that I put at the base to kind of make it a little sturdier, and then I added some tape to tape the card in there. That is sled 1. Sled 2 is just popsicle sticks and tape. And here is sled 3. This is made out of cardboard, 2 straws, 2 pipe cleaners, and some tape at the bottom to hold it together. All right, so those are the 3 sleds. In the seesaw activity you're going to do when you're done watching the video, you're going to tell me which sled you guessed would go the farthest. So make your guess now and try to remember which one you picked. 1, 2, or 3. Before you watch my tests, I just want to make sure you understand that it's really important when you are doing any STEM challenge or science experiment that you make sure your test is fair. So for each sled that I tested, I used the same height and the same smoothness of the hill. If I changed the height or the smoothness of the hill, it wouldn't be fair because maybe one sled would be able to go farther than the other. Also, for each sled, I added 1 weight, which I used a battery to add some weight, and 1 rider. If I gave one sled more weight than another sled, that might also cause it to go farther, and that wouldn't be fair. So you always have to make sure you don't change things in your tests to make sure it's fair. All right, are you ready to watch my sled STEM challenge? All right, let's watch and see which sled went the farthest. Okay, were you surprised at which sled went the farthest? Sled 3 went the farthest. Do you have any idea why sled 3 may have gone the farthest? The only thing I can think of that might have made sled 3 go farther was sled 3 had the two straws at the bottom. Hopefully, you could see that in the picture. So, really, the only surface that was touching the hill, that ramp, were those two straws, which means there was very little friction because there was not much surface rubbing against surface. The other two sleds both were flat against the hill, so there was a lot of surface of each sled rubbing against the hill, which created more friction. So that is my thought as to why sled 3 went the farthest, because there was the least amount of friction on that sled. So now I'm going to show you what I would like you to do in Seesaw. Now that you've watched the video and you saw my STEM challenge, here's what you're going to do. Okay, in today's activity, you're going to click Add Response, find your name on the list, and it will open up this activity. First, I want you to tell me which sled did you predict would go the farthest. Circle your answer. And remember to be honest. Even if you didn't guess the sled that went the farthest, that's okay. A prediction is a guess. You're not necessarily supposed to know the answer before you watch the test. So just use the marker or the pen and just circle the sled that you guessed. I honestly wasn't sure which sled would go the farthest. I thought maybe it would be sled 2, so I'm going to circle sled 2 because that's the one I thought was going to go the farthest. Then, which sled actually did go the farthest? Well, now you know the answer, right? Hopefully you watched the whole video and you saw that sled 3 went the farthest, so you're going to circle that one. This is just my way for me to know that you watched the whole video and you saw which sled went the farthest. When I'm done, I'm going to go up and press the green check mark and submit my activity to the teacher. All right, boys and girls, I hope you enjoyed watching the Sled STEM Challenge. I love doing STEM challenges. I know a lot of you do too, and I hope you enjoyed watching today's Sled STEM Challenge. Have a great day.